This is Mr. Beck Does Your Homework. This is physics homework number 11, questions number 13 and 14. Now the last question got pretty complicated with some forces in different directions and friction. This one does the same sort of thing, but now we're going to be looking for a coefficient of friction. So again, I have two blocks arranged at the end of a massless cord over a frictionless massless pulley. Assume the system starts from rest. When the masses have moved a distance of 0.31 meters, their speed is 1.34 meters per second. Similar to the last one, I know that my initial velocity is 0. I know that my displacement is 0.31 meters. I know that my final speed is 1.34 meters per second, and that's for either block or both blocks together. And I'm looking for, if only I could get my acceleration, I would be in business. Well, to get my acceleration, I do v squared equals v0 squared plus 2ax, and I know my initial velocity is 0, my final velocity is 1.34, and that's twice my acceleration times my distance x, so I can solve for my acceleration from here. Now that I know my acceleration, I know that my acceleration is going to be my net force divided by the mass. Well, my net force, I need to think about those free body diagrams. So this block up here, the 4.7, has gravity down, has a tension to the right, has a normal force up, and has a friction to the left. My hanging block has a gravity on it and has a tension up this way. So my net force on this whole system, well, I know that tension equals tension, so those are internal and those cancel out. I know that normal equals gravity because this is not going to be going up or down and there's no monster, so normal equals gravity. So what's left is the friction on this block and the gravity on that one. So my net force is going to be the difference between this gravity and this friction. So that's going to be my net force is going to be this gravity minus the force of friction. Do I know the force of friction? No, because I'm actually looking for the normal force. I'm looking for the coefficient of friction. So I know that my FF is going to be mu times my normal force, or rearrange this, mu equals FF over Fm. So my normal force is easy enough because the normal force will be the same as this gravity. So this is going to be mg, and then I've got my force of friction on top. But my mg here will be my table block, my 4.7. So my mu is going to be the force of friction divided by mg. That's going to be my 4.7 times 9.8. But how am I going to get my force of friction? Oh, well, looking up here, my net force is easy enough because my acceleration is my net force over my m, and my m is my total moving mass. So my F net is also going to be my mass, which is both masses, times my acceleration. Since I know my acceleration, I can solve for my F net. So now I know F net. If I know my net force and I know the force of gravity on this hanging block, then I can get my force of friction. So my force of friction is going to be added to both sides, subtract F net. It's going to be Fg minus F net. And this Fg is the hanging mass, remember. So my force of friction is going to be, my Fg is going to be 3.4 times 9.8 minus my F net that I solved right there. So now what do I know is that this is going to be my force of friction. Force of friction equals that. And so that is going to go up top, and that will allow me to solve for my coefficient of friction, my force of friction from here and my normal force from there. That will be my answer to that one. Then it says, what is the magnitude of the tension in the cord? To get the tension in the cord, I need to look at any one of these free body diagrams. How about this one? I know that this block is accelerating at this rate because either block is accelerating at that rate. So on this one, I know that my net force is going to be gravity down minus tension up. Now this time I'm dealing with this gravity and this tension, so that's my net force on this smaller block. So that net force, I know the acceleration, so I know this is going to be the mass times acceleration. Not g. This is going to be the mass times the acceleration that I figured out before, way over here, because either block is going to be doing the same thing. That is going to equal the force of gravity on this block, the 3.4 kilogram block, so that's mg minus the tension force. So now I can solve for my tension because it's going to be, move this over, so my Ft is going to equal my mg of just the small block minus ma of just the small, the a from everything, but that's the mass of the small block. Hopefully you can figure that one out. And if you notice, the m's are going to factor out, so I could also say that my tension is going to be mass times g minus a. That'll give me my force of tension.